Okay, we kind of got cut off on that last video. So we were looking at the domain for part B, moving from left to right. We saw it started at 1 and then it goes to infinity because we can see as our pencil moves to the right, it's going to keep hitting x values. Okay, let's look at our range. So we're looking at the bottom and moving up. Well, we can see you kind of have to imagine this line is going to be going on forever, and it might take a while, but it's going to get to infinity. It's going to be going to infinity. And so same thing up here, we're continuing in an upward direction, and so this one will be negative infinity to positive infinity, again with parentheses. Okay, C. Hopefully you're starting to see the trend when we have these lines that are coming out to the side. I'll draw that a little more accurately. We can see it's going to be negative infinity to infinity. So our pencil, again moving to the left, is always going to be hitting a value. And so negative infinity to infinity. And then the range, we're moving up. And so we start, it looks like -3. Oh, and I messed up. I just realized this. I messed up on that one. That was a -1. Hopefully you caught that. You caught that mistake, so you don't make that mistake. So this range should have been a -1. And I'm thinking, yep, that looks like -3. So it's including -3. So should it be a parenthesis? No, it should be a bracket because it's including -3 and it's going up to infinity. Okay, last one, we've got this little X in the middle. Sorry about that. But we'll again look, moving from left to right. The first X value we hit will be at 1. And it's including 1. And then we can see with that arrow, it's going on forever, so it'll go to infinity. Okay, range. So we're moving up from the bottom. The first Y value we hit will be right here, 2. So that line is the first place we cross. So 2, it'll be a bracket because it's a closed circle, it's including 2. And this one, it'll take a while to get to infinity, but it does go up to infinity because it continues upward. Okay, these ones are a little bigger. Hopefully we can see, in fact, I'm going to make them even a little bigger so we can see those numbers nice and clearly. So domain, we're going to be looking for x values. So we think of our line moving from left to right. The first x value we hit is going to be at -1. Now this is an open circle, which tells us it doesn't include -1, and so it needs to be a parenthesis there. So we keep moving. The last x value we hit will be right there at 2. It is including it. It's a closed circle, and so it has to be a bracket. Okay, range. So think of our line moving up. The first y value we hit is right here at -3. It's a closed circle, so it's including -3. We keep moving up, and it looks like the last one will be where y equals 0, right here. Okay, so y equals 0, it's an open circle, and so it'll be a parenthesis. Okay, F. Now I want to encourage you, pause this video and try this one on your own, and then restart the video and see if you got it right. Okay, just to kind of check for understanding. Okay, domain. So we're moving left to right. The first x value we hit is at -2. It's a closed circle, so it'll be a bracket. We get to 1. It'll be a parenthesis because it's an open circle. Okay, range. So think of moving bottom to top. So the first value we hit is where y equals 0. Closed circle, so it'll be a bracket. And then the last y value we hit, it might be tempting to think this one, but is that the last y value? It's not. Notice this graph goes clear up through where y equals 4. And so 4 is actually the last spot we hit. And it is including 4. Okay, so make sure we actually look at the graph and not just at those points. We want to see that top point on that graph. Okay, let's look a little more closely at functions, and we're going to look at function notation. So if a relation is a function, we can use function notation f of x, which is read as f of x. So note y equals f of x. So instead of writing y, we use f of x. So for example, you might be used to seeing something like y equals 2x plus 1. Well, you might see it as f of x equals 2x plus 1. Just remember that f of x is the same as y. It's just saying we're a function of x, okay? This also says x is the input, the independent variable, and f of x is the output, the dependent variable. So kind of like what we were talking about before with domain and range, we have our input x and our output, in this case, f of x. So what will happen is you'll be given functions. So in this case, we have g of x, we have f of x, and we have h of x, and we need to find the different values. Notice here, 0 is in place of x. So for part A, what we'll be doing is just putting 0 in place of x. So another way to think of it is it's just like, okay, what does g of x equal when x equals 0? So we can write out the function. We have 4 times x plus 5. We want to make sure the whole function is written out, and then we just put 0 in place of x. So 4 times 0 is 0 plus 5, and we just get 5. So g of 0 then equals 5. Okay, let's look at D. We'll look at f of negative 1. So f of negative 1, we have 3x squared minus x plus 2. Notice I'm doing parentheses everywhere that I need to substitute the value in. So f of negative 1, so I'll just put negative 1 in place of x, and then we want to do order of operations. So first parentheses, there's nothing to simplify inside the parentheses, and so next I'll move to exponents. It may be tempting to multiply 3 and negative 1. That's a very common mistake, so make sure you do exponents first, which would mean negative 1 squared. So we have 3 times negative 1 squared. Well, negative 1 squared would just be a positive 1. And now we can multiply. 3 times 1 is 3. And this is kind of like multiplying. Well, there's a couple different ways to think of it, but when we're minusing a negative number, it'll become positive. So 3 plus 1 plus 2. And now that we're adding, we move from left to right. So 3 plus 1 is 4, plus 2 is 6. Okay, so that's our final answer. Okay, last, let's look at g of x plus 1. Actually, we'll do one more. So again, I'm going to write out the whole g function. So 4 parentheses where the x is plus 5. Now what goes in place of x? Well, in this case, x plus 1 goes in place of x. Okay, now we simplify, so we can distribute that 4 in. 4x plus 4 plus 5. So that becomes 4x plus 9. And that will be your final answer. We can't solve anything, so this will just have to be simplified as far as it can go. So just keep in mind whatever is in those parentheses, that's what you're putting in place of x. Okay, we're going to do g as well because g is a little bit different. So on this one, we need to determine x when g of x equals negative 3. So we know g of x is 4x plus 5, but here they're telling us, okay, find x when g of x equals negative 3. So that means we put negative 3 in place of g of x. So equals 4x plus 5. And so now we solve for x to find out what x equals. So we subtract 5 from both sides. We get 4x equals negative 3 minus 5 will give us a negative 8. Divide by 4, so then x would equal a negative 2. If you wanted to check this, you could even substitute negative 2 in for x and make sure it does equal a negative 3. Okay, let's look at finding values a different way by using the graph. So we're given the graph of f, we need to find each function value. So f of negative 2, this means when x equals negative 2, we want to find f of x. Okay, so let's find where x equals negative 2. X equals negative 2 right here. And so we can see f of x equals a negative 1. So the answer then would be negative 1 on that one. Okay, you try f of 3, try pausing the video and finding it, and then check here. So f of 3, we're going to be right here. This is where x equals 3, and we want to find out what does f equal at that point. So f of x, we can see, is just going to be 0. Another way you can look at it is you can say, hey, I know that point is 3, 0, so x is 3, y, or the f of x in this case would just be 0. So 0. Okay, C, find all values such that f of x equals 1. And if it's hard for you to remember, just put in y equals 1. So where y equals 1, we want to find the x values. So y equals 1 here, we can even draw the line all the way across. So where y equals 1, we are going to have x equals -4. And also, I've got to erase a little bit here. Okay, there we go. So we have x equals -4 and also x equals 4. So x would equal -4 and 4. And then similarly with -2, when we're at -2, it looks like our two values will have one right here and one right here, so -1 and 1. Okay, example 6, we have the function f of x equals 0.55x plus 0.3. Approximate the number of students enrolled in an online class in millions, given x is the number of years since 2000. So approximate the online enrollment in fall of 2008. So notice x is the number of years since 2000. And so if we're looking at 2008, we're going to have x equals the number of years after 2000, so 8. So now that we have x equals 8, we're trying to find the enrollment, and so we plug 8 in for x. So we will have f of 8 equals 0.55 times 8 plus 0.3. So that equals 4.7. If you do order of operations, notice it's in millions, and so it would be 4.7 million. Okay. 7, use the given function to answer the following questions. So we have f of x equals this function. We need to evaluate f of 1. So basically where x equals 1, what does y equal? Well, we have the 0.17, so when x is 1, y is 7. Determine x when f of x equals 5. So again, remember this is like y equals 5. Well, y equals 5 right here, so x would be -3. Similarly here, evaluate f of 1. So this video is actually just about to end, so I'm going to have to cut it off here, so I will leave that one to you. But ask me if you have questions or if you'd like to see a video of it.